All right, 1.5, parametric relations. And inverses. So inverses, not super hard. We've done that before. It's just the parametric stuff that's going to be a little different than what you are used to. So, let's see. Find the XY pair for the value of the parameter. And so they basically give us an X equation and a Y equation with respect to T, and then they tell us what T is equal to. So X is equal to 5T minus 7, Y is equal to 17 minus 3T, and this is for T is equal to negative 2. So all we're doing really is plugging negative 2 in for T and getting an XY pair for these ones. If they don't give you a number that's getting plugged in, we do things a little differently. But since we have something that's getting plugged in, we just go with it. So X is equal to 5 times negative 2 minus 7. So negative 10 minus 7 is negative 17. And then Y is 17 minus 3 times negative 2. So 17 plus 6 is 23. So XY pair is negative 17, 23.
Me too.
Huh?
That's a little more my
speed.
Yeah.
The nice thing about this section is it's really not that hard. It's just weird. Like, I don't know. That's why I'm like, I think there's like more to it that we need to do, but that's what this book does, so I feel like I'm gonna have to go pull like resources from somewhere else to really. But yeah, we'll have to see. I'm hoping that there's a like, because like I have prep books for stats and calculus, but I don't have one yet for pre-cal because it wasn't done this summer. So I like told Mr. Law that I was gonna want one when they came out, but they weren't out yet. So I need to do some research in the next like week or so and see if they have one out yet, and then ask him to order one, so that, and if they do, I usually give you like pages that like I don't like pull the pages out, but I usually copy pages to give you. But if you want like extra practice, I would suggest like getting one for home. They're usually like $20 to $25, and you can get them at like Barnes and Noble. But I can tell you which brands are usually pretty good too and more helpful. Once I find one and I actually get it in hand, I'll let you know. Okay. So you don't really need it. I've never had a student actually get one before, but if you feel like you want extra practice or something like that, usually I will pull what I think is helpful for you. But obviously there's usually like 9 practice tests, and I have no way to go over that many practice tests with you. So, all right, so X is equal to the absolute value of T plus 3. Y is equal to 1 over T, and T is negative 8. So X is equal to the absolute value of negative 8 plus 3, which is the absolute value of negative 5. So X is equal to 5. And then Y is equal to negative 1 over 8. So my ordered pair is 5 and negative 1 over 8.
These are nice and easy.
All right, these next ones, I'm going to show you, or do y'all have your books?
Yeah.
If you have your books, just because it'll be easier to see it. On page 119, there's an example of what we're about to do that they've worked out. So I'm going to because there's like a lot of steps to the next part. So basically defining a function parametrically. So it says to consider the set of all ordered pairs x and y defined by the equations, and then they give you two equations with respect to t. And so it says to find the points determined by t is equal to, so they give you, what is that, 7 values for t. So basically we're going to be making a table, okay? So they've made the table down here. So they put in the values of t, and then we have to find the x and y values. So we kind of just did it for one value in the last problems that we just did. Now we're doing it for 7 values. And then what we're doing is basically writing what the ordered pairs are for each one. So find an algebraic relationship between x and y. This is often called eliminating the parameter. Is y a function of x? And so what we do then is this part B. And it says we can find the relationship between x and y algebraically by the method of substitution. First, solve for t in terms of x to obtain t is equal to x minus 1. And so basically what we're doing is we're going to get t by itself in like one of the equations, and then get whatever we got for t and plug that in for t in the other one. So like if y is easy, or well, typically we're going to do it for x. So we're going to solve for t in terms of x then. Get t by itself in that equation, then take that t value and plug it in for y, or in for t in y. And then basically go from there and decide if it is, whatever it said, a function of x. So there's, so this one, they got t is equal to x minus 1, and then they replaced t with x minus 1, and just simplified it down to x squared minus 1. And so it says this is consistent with the ordered pairs we had found in the table. As t varies over all real numbers, we will get all the ordered pairs in the relation y equals x squared minus 1, which does indeed define y as a function of x. And then they graph them. I'm not really worried about graphing them because it's basically plotting points or just graphing a parabola in this case. So I think that's all of that. Yeah. So we're probably only going to do one. I think there is some way you can do it on your calculator, but I honestly haven't done it in like forever, if ever, because when I took pre-cal, we didn't really do anything with parametric equations, which I know sounds like super crazy, but we just wasn't part of our curriculum, so we didn't do it. So we're going to be doing it for -3 to 3 for t as well. So basically when we do our table, you're going to need like basically 8 lines. So x is equal to t plus 1, y is equal to t squared minus 2t. So this one's going to be very similar to the problem that we just looked at in the example. So I'm going to go ahead and set up a table. So we're going to need 4 columns, and it basically ends up being 8 rows because this top one is going to be where you're putting all your values. All right, so the numbers that they told us to plug in for t were -3, -2, -1, 0, 1, 2, and 3. So now we're just plugging each of those numbers in for t. So I'm going to do all the x's, and then I'll do all the y's, and then we'll make the ordered pairs. So negative 3 plus 1 is negative 2. Negative 2 plus 1, negative 1. Negative 1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4. And then for y, we've got, okay, this one's going to take a little bit more thinking. Negative 3 squared is 9. And then plus 6, so 15. Negative.
Isn't it minus 6?
Well, it's negative 3, so minus, or so negative 2 times negative 3. The one for 3 will be minus. So negative 2 squared, so that's going to be 4, plus 4, so that's going to be 8. Or negative 1, it's going to be 1 plus 2, so it's going to be 3. For 0, it's just 0. For 1, we have 1 minus 2, so that's going to be negative 1. 2, that's going to be 4 minus 4, which is going to be 0. And for 3, it's 9 minus 6, so that's going to be 3. So then just take those and just make ordered pairs out of them. So negative 2, 15. Negative 1, 8. 0, 3. 1, 0. 2, negative 1. 3, 0. And 4, 3. So then part B says to find a direct algebraic relationship between x and y, determine whether the parametric equation determine y as a function of x. So part B, this is where we're solving for t. So we had t, or x is equal to t plus 1. So that means that t is going to be equal to x minus 1. So then y of t is basically anywhere we have a t, we're replacing it with x minus 1. So that would be x minus 1 squared minus 2 times x minus 1.
How did we get x minus 1?
Because I solved for t, so I subtracted 1 from x. And got t by itself.
Wouldn't it be negative x because you moved it to the other side?
I moved the 1 over here.
Oh,
I just wrote it backwards because I like the thing I'm solving for to be on the left.
got it.
So yeah, technically x minus 1 is equal to t is what it should be written as, but I just put the t on the other side. So then this x minus 1 squared is x squared minus 2x plus 1, and then minus 2x plus 2. So this ends up being x squared minus 4x plus 3. So is that a function? Yeah, still makes a parabola. So y is equal, or hold on, so not y is equal to, that is y. So yes, y is a function of x. And so just something to note, because it probably wasn't written in your notes, is that parametric equations allow us to graph curves that are not functions. Do y'all remember what or how to tell if like a relation is a function or not?
It can only have one y value for each x.
Yeah, every x can only have one y value, but y values can be used twice. They just have to have different x values. So like this one, the x values were used once, but there were a few y values that we had twice on there. So, and that's the nature of the fact that it's a parabola. So, all right. The next ones you still need your book to look at because it's 10 and 12. So they ask you for, they say the graph of a relation is shown. Is the relation a function? Okay, so remember that is going to be with a vertical line test that we're going to tell that if it intersects anywhere twice, it's not. And then does the relation have an inverse? That is a function. And so that's the horizontal line test that will tell us that. And that can only intersect going like down one time. So with 10, we've got something that kind of looks like a sine function. I mean, it's not exactly that, obviously, but kind of looks like that. So does that pass the vertical line test? Yes, it does. So that is a function. So part A is yes because of the vertical line test. And I'll just use VLT for vertical line test and HLT for horizontal line test. And so then does the relation have an inverse that is a function? So does it pass the horizontal line test? No. And then same thing for 12. So 12 looks like a sideways parabola. So does this pass the vertical line test? So is it a function?
No.
No. And how about the horizontal line test? Is the inverse a function? Yes. Where are we at time-wise? I'm going to do one inverse problem for you just to kind of intro it, and then I'm going to go ahead and give you the problems that go with what we've done so far, and then we'll do inverses on Monday. And then we should basically be done with this section unless I see other stuff that we need to do with this. But if you can do this stuff, I think you should pretty much be fine. So these say to find the formula for f to the negative 1 of x, so that just means the inverse. And it says to give the domain including any restriction. So we'll pretty much just talk about it, probably not explicitly write it down, just so that you're familiar with it, should it come up. So 14, we have f of x is equal to 2x plus 5. So obviously remember f of x is just y. And so anybody remember what we do to find an inverse? Or what
Switch the x and the y.
Yeah, swap x and y and then do what? Don't look it up. What would you logically think I would do once I've swapped x and y? So I now have x is equal to 2y plus 5. And I need an equation that is f to the negative 1 of x.
So we do
Solve for...
the reciprocal.
I was like, what does that sound? Solve for y. Okay, swap x and y, solve for y.
I was gonna say that, I was just scared.
So x minus 5 is equal to 2y. Now, I'm going to put the y on the other side now. So y is equal to, I divide by 2, so x minus 5 over 2. So you can leave it this way. Some people will rewrite this as 1/2 x minus 5/2. Either way is fine. So that's just a linear equation, right? So what is the domain of that? Yep, all real numbers because it's just a line. All right, I'm going to stop there and we'll pick up that on Monday because I want y'all to be able to go ahead and do the stuff that's specifically parametric at this point. And so that's going to be, and I mean, you don't necessarily have to do it right now, but at least you could if you wanted to. 3, 5, 9, and 11. So 5 will be the one that's a table. 9 and 11 are just looking at a graph, so this one should be pretty easy. 5 will take you the longest probably, just because it's tedious.